We're told it's just rock, barren and lifeless. But what if the moon's hidden face, its true dark side, has silently manipulated human history, whispering secrets into our collective unconscious for millennia? From the dawn of humanity, we have gazed skyward, our imaginations captivated by the celestial ballet above. The moon, our closest cosmic companion, has forever been a subject of myth, poetry, and relentless scientific inquiry. For centuries, its consistent face, ever present in our night sky, fostered a profound mystery. What lay on the other side? This enigma gave birth to the popular, albeit misleading, phrase, the dark side of the moon. Fueled by cultural touchstones, from Pink Floyd's iconic album to countless sci-fi narratives, the idea of a perpetually shadowed alien realm has firmly taken root in our collective consciousness. Yet the truth, as science often reveals, is far more nuanced and fascinating than fiction. The moon doesn't have a dark side in the sense of one hemisphere always being unlit. Just like Earth, the moon rotates, and every part of its surface experiences both day and night. So if it's not perpetually dark, what then does the dark side of the moon truly refer to? It speaks to a profound observational challenge, a hidden lunar hemisphere that remained entirely unseen by human eyes for almost all of recorded history. This unseen face, which we now accurately call the far side of the moon, holds secrets vital to understanding not just our natural satellite, but the very origins of our solar system. This documentary delves into that fascinating truth, exploring the science behind why we only ever see one face, what makes the far side so uniquely different, and the cutting-edge research finally shedding light on its enduring mysteries.
The reason we only ever see one face of the moon is due to a phenomenon called tidal locking. It's a cosmic dance dictated by the relentless pull of gravity. Imagine the Earth's gravitational force acting on the moon. This force isn't uniform across the lunar body. It's stronger on the side closer to Earth and weaker on the far side, creating a slight gravitational bulge on both sides of the moon along the Earth-Moon axis. Early in its history, the moon rotated much faster than it does today. However, Earth's gravity exerted a constant torque on these bulges, gradually slowing the moon's rotation until it reached a point where its rotational period precisely matched its orbital period around Earth. This gravitational synchronization means that for every revolution the moon makes around our planet, it also completes exactly one rotation on its axis. The result is that one hemisphere is perpetually oriented towards Earth, while the other consistently faces away. For billions of years, this celestial ballet kept the far side of the moon hidden from our view. It wasn't until October 7, 1959, that humanity caught its first glimpse of this mysterious realm, thanks to the Soviet Union's Luna 3 probe. The grainy, black-and-white images it transmitted back to Earth were revolutionary, revealing a landscape starkly different from the familiar face of the moon we'd known for millennia. This first peek ignited a scientific curiosity that continues to drive exploration even today.
What Luna 3 and subsequent missions revealed was a lunar hemisphere remarkably distinct from the Earth-facing near side. The most striking difference is the conspicuous absence of large, dark volcanic plains, known as maria, which dominate the familiar face of the moon. The far side is overwhelmingly characterized by rugged, heavily cratered highlands, ancient, pockmarked terrain that speaks to a violent early history. While the near side boasts expansive maria like the Sea of Tranquility, the far side has very few, and those it does possess are considerably smaller and sparser. Scientists believe this asymmetry is due to fundamental differences in the moon's crust. The far side's crust is significantly thicker and more ancient than that of the near side. This thicker crust made it much harder for molten rock from the moon's interior to breach the surface and form the smooth basaltic plains we see on the near side. Additionally, models suggest that radioactive elements, which generate heat, were unevenly distributed within the early moon, leading to greater volcanic activity on the near side. The far side also hosts the largest and oldest impact structure in the entire solar system, the South Pole Aitken Basin, a colossal scar stretching approximately 2,500 kilometers across and 8 kilometers deep. This immense basin offers a unique window into the moon's interior and the intense bombardment it endured in its early days, preserving a pristine record of the solar system's tumultuous youth, less altered by subsequent volcanic resurfacing.
Exploring the far side presents unique challenges, primarily due to communication. With the Earth always on the opposite side, direct radio signals are impossible. This hurdle necessitated an ingenious solution: relay satellites. China's ambitious Chang'e program has pioneered this new era of far-side exploration. In 2018, they launched Kuekiao, a communications relay satellite, strategically placed in a halo orbit beyond the moon, allowing it to maintain line of sight with both Earth and the far side. This breakthrough paved the way for Chang'e 4, which in January 2019 achieved a historic first: the soft landing of a spacecraft on the lunar far side. The Chang'e 4 lander and its Yutu-2 rover have been meticulously studying the geology and composition of the von Karman crater within the South Pole Aitken Basin. One of its key scientific objectives is low-frequency radio astronomy, leveraging the far side's unique position as a radio quiet zone, shielded from Earth's terrestrial interference. This allows for unparalleled observations of the early universe, free from cosmic noise. Building on this success, China recently launched Chang'e 6 in May 2024, an even more ambitious mission aimed at collecting lunar samples from the far side and returning them to Earth. These invaluable samples could provide unprecedented insights into the moon's asymmetrical evolution and the conditions of the early solar system. The dark side of the moon, once a realm of mystery and misconception, has transformed into a beacon of scientific discovery, promising to unlock secrets that could redefine our understanding of our own cosmic origins.
Subscribe to the channel and hit the bell icon for more amazing videos.